Problems 15, 16, 17, and 18. Solve each equation without a calculator. Give answers as an exact value. So starting out, we've got number 15. It says log base 16 of x equals negative 1.5. So on this one, right, I have one log statement on one side of the equation. So remember, our goal here usually then to solve it is we will take it and we will rewrite it in its exponential form. So right now I've got 16 to the negative 1.5 power is equal to x. Okay, well, negative 1.5 power is actually like saying 16 to the negative 3 halves, in which case we can do this without a calculator, right? Let's take this and let's break down 16 to the negative 3 halves power. So first of all, let's do 16. And we're going to say this is raised to the 1/2 power, and then that is being raised to the negative 3rd power. Right? When I multiply 1/2 times negative 3, it's back to negative 3 halves. I just separated it here because I know that 16 to the 1/2 is really the same thing as saying the square root of 16 to the negative 3rd. Well, square root of 16 is 4. So we have right now 4 to the negative 3rd. Now, if you're still not good with these, let's think about it like this. This is like 4 to the 3rd power, and then we can deal with the negative. 4 to the 3rd power is actually 64. And if you take 64 and raise it to the negative 1st power, we're going to take the reciprocal of the base, which gives us 1/64. That is the value of x in number 15. I guess I lost track of my equation, but that was what x equaled there. All right, let's look at 16. Number 16, we have 4 to the power of negative x equals 8 to the power of x plus 2. So this one is an exponential. And when we've got an exponential equation, remember one thing we want to check, can we rewrite as the same base? So in this case, we can, right? 4 and 8 both can be rewritten as 2 to a power. So if we write this as 2 to the 2nd power, and we raise it to the power of negative x, and 8 we can call 2 to the 3rd power, and then it's still being raised to the power of x plus 2. Now we'll just apply that property here that says when we raise a power to a power, we multiply. So we're looking at 2 to the power of negative 2x is equal to 2 to the power of 3x plus 6. I just distributed it through. And now that our bases here are the same, we can drop them and just go ahead here and focus on our exponents. Because in order for these to be true, the exponents would have to be the same thing. So when we solve this, we're going to have a negative 5x is equal to 6. We divide each side by negative 5. And we're going to get that x is equal to negative 6/5. Now you can go through and check it as well, but for time's sake here, I'm going to let you know that it definitely works out. All right, so then let's look at number 17. 17 is also exponential. Okay, but it looks a little different here. So remember, when we're trying to do these exponentials, when we realize we've got one that we can't rewrite as the same base, then we need to get it into that form where it's a base raised to a power equals a value, or a base with an exponent equals a value. So what we need to do here is we need to get rid of this 2 on each side. So we're going to subtract it. We've got 5 to the power of 2 minus x is equal to 4. And now it more resembles this, right? So what we're going to do here is we're actually going to take this, when it's an exponential, we want to turn it into a log. So let's use our definition of a logarithm here. We're going to say we have a log base 5 of our value 4, right, is going to equal our exponent, which would be 2 minus x. And all we're going to do here now is we're going to take this and we're going to subtract our 2 from each side. We have log base 5 of 4 minus 2 is equal to negative x. Now remember, this 4 is what we're taking the log of, not the minus 2. And then we're going to have to divide by a negative 1, and I'm just going to divide each term by negative 1 on the other side. And our final answer, right, we're going to have this expression negative log base 5 of 4 minus 2. I'm sorry, plus 2. Haha, fooled you, right? Because negative 2 divided by negative 1 would be plus 2. And that is going to be our answer for number 17. All right, last one from this little part here. We got 18. Now we've got another log equation. And again, we only have one log on one side, right? So since this log is in its form here where we've got, the log, we've got a base, we've got a value, and it equals our exponent. Since we don't have anything additional going on, let's just take this and do our giant spiral to rewrite an exponential form. So 3 to the power of 0 should equal x squared minus 1. Well, 3 to the power of 0 we know is 1. So 1 equals x squared minus 1. If I add 1 to each side here, I'm going to have 2 is equal to x squared. And now when I take it here and I want to take my square root of each side, I have to remember that the square root of x squared is going to be the absolute value of x, which should equal the square root of 2. And that simply means that x should have to equal positive or negative square root of 2. And that is our solution. Now for that one, you always want to make sure you take it and you go back and you plug it in here, right, into this area of our equation, because we don't want to end up with a negative in there. But in this case, when we square negative or positive radical 2, we're still going to end up with 2, and so that one should end up working out. All right, that is 15, 16, 17, and 18 from the Chapter 3B quiz review.